In this second video dedicated to protecting groups, I'm going to be looking at specific protecting groups that can be used to protect hydroxyls. What can you do to protect an alcohol, a hydroxyl group? Well, the typical four courses of action is to convert your alcohol to an ether group, to convert it to an acetal, to use a silyl ether group, or if you have a diol, to convert it to a ketal. So for example, this is a reaction in which an alcohol group is converted to an ether to protect it. So in this case, it's not so much that you are converting it to an ether, but you start with already the ether. So you start here with a methoxy group. You do a series of reactions to produce this part of the molecule, and then when it's not necessary anymore, you can liberate your ether and reform a hydroxyl group. The second reaction again involves the the protection of an alcohol by converting it to ether. And in this case, you do not start with ether already. You start with a molecule that has a hydroxyl group, and you use OBN, which stands for benzyl ether, and that protects the hydroxyl group and make it into an ether group. You then do several synthetic steps to form the rest of the molecule, which ends up with two fuse 6-member rings. And again, you still keep the benzyl ether group here, protecting your hydroxyl group. And finally, you liberate the hydroxyl group by using sodium with ammonia and tetrahydrofuran, and you recuperate that hydroxyl group. So this is quite a complicated synthesis. It involves quite a few steps, but that hydroxyl group has not intervened in any of those steps because it's being protected as an ether throughout the whole synthesis. This is an example of protecting a hydroxyl group by converting it into an acetal. And in this case, the hydroxyl group is protected by a silicon compound rather than a carbon one. So you form this acetal here. This OSCM would be the same as writing oxygen, the other oxygen, and the SIM3 compound fragment. You do a series of reactions that change the molecule, and this group is protected, and this hydroxyl is protected. And when it's time to liberate the hydroxyl group by using an ammonium salt and in DMF, dimethyl formamide, you liberate the hydroxyl, the hydroxyl group. This is an example of how you can protect a hydroxyl group by using a silyl ether protecting group. The most common one, not the only one, but the most common one is trimethylsilyl ether. So as you see here, you've got the hydroxyl group you want to protect. You use trimethylsilyl ether, and you form the ether with the silicon. You do a sort of steps that to aim for the target compound, and when you are ready to liberate the hydroxyl group, to recuperate the hydroxyl group, you use again an ammonium salt and in THF and liberate the original hydroxyl, and the rest of the molecule has changed, but that hydroxyl has not interfered in any of the reactions. This is an example of a reaction in which you protect two hydroxyl groups by forming a ketal. So the aim is to protect these two hydroxyl groups. And if you notice, this reaction, it already has a functional group which is protected. That TIPS stands for triisopropyl silyl. So the two hydroxyl groups are converted to a ketal. Then various steps happen and the rest of the molecule changes. And then in the use of strong acid, perchloric acid, you liberate the original hydroxyl groups in the diol, while the rest of so those two hydroxyl groups have been protected while the reaction has taken place, and the rest of the molecule has been modified. And then as a final step, those two hydroxyl groups are liberated to return to the original, are deprotected to return to the original diol.